Unit 3, Section 5 for Honors Math 2 is still on proofs. If you're not good with proofs, I'm sorry, but this is where we put it all together. We put everything that we did before together. We add one or two more new things, and then we say, do you really understand? So, first thing I need to let you know, everything that I assigned in this particular assignment, in the 3.5 Delta Math, they cannot give you any partial credit, or if you give up, it gives you a 0 for the assignment. You don't get a new problem. So keep in mind, I gave you 9 problems. You have to do all 9 to get 100% on the homework. If you get stuck and you don't do this problem, it will discount it as a 0 and you get credit for whatever you complete. Just like anything else, the only difference is you can't say, I give up and think you're going to get another one. Otherwise, I have to reset the whole assignment and mark everything like you never did it in the first place. So keep in mind. Plus, you're going to be all getting the same questions so you can work together. You're going to be put into groups. Keep that in mind. That's why you've been working on talking to each other. So the one new thing that we're going to use is something called Cpctc. It stands for the corresponding parts of congruent triangles are congruent. What it basically says is if I can prove two triangles are congruent to each other, then all their parts are also congruent. For example, if I say triangle ABC is congruent to triangle ABC, A, then B, then C, then CDA, triangle CDA, just checking. If I say that the red triangle is congruent to the white triangle because I've proved it by angle, side. I used angle, side to prove that they're congruent. Even though I done angle, side, I can now say that DC is the same as AB because of Cpctc. Their parts are also congruent. CD is the same as AB. This part is the same as that part. Or this part is the same as that part. Once you prove that the two triangles are congruent using one of the 5 shortcuts, their other parts, their other angles or sides are also congruent because of something called Cpctc. And I have that memorized, Cpctc. Corresponding parts of congruent triangles are congruent. I'm not even reading that, I'm just going off the top of my head. I expect you to know it. So these proofs that we're about to do, everything's pretty much the same as what we did in 3.3, except we do same step 1, the same step 2, but in step number 3, we're going to use Cpctc to prove that the parts of the triangles are also congruent. And that will help us to state anything else that needs to be stated. Well, because of that, we are going to do 3 types of problems: proof correctness, reorder steps, and reasons only. For proof correctness, they are either going to be correct or incorrect. If they're incorrect, you will have to state which step it was wrong and why is it wrong. Was it a wrong reason or was it a missing step? And then you're going to have to make that decision. For example, if I go to this particular example and you see this proof, you're going to look at it and you're going to say, okay, is the given, does that match? Let me just hit this button real quick. Does all of that match up right there? That's a true statement. And then you're going to look at it. Let me clear that out. And then you're going to look at step 2. Let me clear that out. Turn that off. And you're going to say, is CDB a right angle? And can you say that after looking at step one? So I'm going to look at this, and then I'm looking at step one, and I'm going to decide, because of this, can I say that? And maybe you go, yeah, that's a true statement. And then can you say angle ADB is congruent? Can you say that these two angles are congruent to each other because all right angles are congruent? Well, you said this is a right angle. And that's this piece right there. Did you ever say that this is a right angle? So what you're going to have to do is you're going to have to look at this and say, this proof, is it correct or incorrect? And step number, well, this is correct, but I don't think we can say that number 3 yet. I don't think we can say step 3 yet is the first unjustified step due to a, is it because it's missing or is it because it's the wrong reason? I believe it needs something else first, doesn't it? And then we'll submit that and we'll see if we got it right. So you'll have to look at proofs to see if they are correct or incorrect, and then state where and why they are incorrect if they are. You have 3 of those. Reorder steps. You're going to have these proofs that have all the steps in them, except they're mixed up. It's the statement and the reason are correct. They're just not in the right order. So what are my hints for you? First, given's always the first step. Make sure it's at the top. What you're trying to prove is always the last step. Make sure it's at the bottom. You need 3 pairs of congruent sides or angles before a congruency statement. Before you get this triangle is congruent to that triangle, make sure you have all 3 sides or all side angle side or angle side angle, or I don't remember which other ones I said. HL. Lastly, you need Cpctc to come after any congruency statement. So keep that in mind. Those are the things you want to think about as you are getting into looking at which proofs and why they are wrong. For example, if I look at this question and I see all these steps, trust control minus, make it a little smaller so I could see everything on the screen. One more time. Good. That's everything. There's everything that you can see. There's step 1, there's step 7, and it's a proof and you have to decide. So one thing I want to point out to you, you can't have Cpctc before a side angle side. So I can click, drag, move it up. That has to happen before that. Cpctc has to happen after a congruency statement. Well, let's go back to our notes real quick. Given is always the first step. Let's check and make sure, okay? Given, 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 given. Okay, so that's done. What you are trying to prove is always the last step. What are we trying to prove? We're trying to prove that BD bisects AC and that BD is perpendicular to AC. So I might have this one at the bottom, or I might have the BD is perpendicular to AC at the bottom. I'm not sure whether it's going to be this one or something different, but that just kind of gives me an idea. Okay, so what your job is you need to figure out, okay, do you have enough information here to prove that it's side, angle, side for these 2 triangles? Well, let's look. You have an angle, you have a side, you have an angle in step 1. You need something else before you can do side, angle, side. This is not in the right order. Well, what else could I use? If I have that side and that angle, is there something shared? Here's the step. What if I did that next? What if I did side angle for step 1, then used the reflexive property for BD congruent to BD, side angle side? Would that then allow me to say that the left triangle is congruent to the right triangle because of side angle side? And then, is this angle part of that triangle? Or is this angle part of these two triangles? Is it Cpctc? Corresponding parts of congruent triangles are congruent. Yes, so that's fine. Is AD congruent to DC? Are those parts of these congruent triangles? And all you have to do is look. AD is the first and third letter. Is DC the first and third letter? They're parts. ADB, is that the same thing as CDB? Look at how those are parts of this congruency statement. In other words, that's what Cpctc stands for. So I agree, I like it. Does BD bisect AC? BD bisects AC. Well, this has to come after. If these two things are equal, then does BD bisect AC? A segment bisector intersects a segment to form two congruent segments. Well, because those two are congruent, doesn't it bisect? And then if two lines form a linear pair of congruent angles, linear pair of congruent, then the lines are perpendicular. Pretty sure that this follows that, right? I'm pretty sure we can mix up some of these steps. And I'm wondering right now, if this is my proof, I'm wondering, let's go and show all. Let's see what Mr. Delta Math did. They went side angle side, then these, then bisects, then corresponding parts, then the angles and the perpendiculars. So keep in mind, there are more than one acceptable answers for these, but certain things have to follow as you go. The last example that you have to do are reasons only. These are proofs where the statement is given to you, but your reason isn't there. All those reasons come from things you should already know. For example, normally, I edit this out, but this is my 4th time recording this, and I'm kind of like, you get what you get. I'm sorry. For the reasons only, they're gonna have the proof. You just have to find the reason why is AC congruent to AC. It's something that we did in our notes. It will keep building. And don't forget, Cpctc is going to be a part of this because you're going to have to end up proving something along the way. So that's as far as I am going to get. You will be working together on this. I recommend sharing your screen when you guys are in your breakout rooms. And I hope that together you're able to get through this whole thing. Good luck.